Hi, this is Koiro with a short video, and this is a general repair video, and this is a short follow-up from my last video where I did the keyboard on the MSX Omega computer, and I also showed a more in-depth guide of why capacitors fail and what you have to look out for. And this is just a general repair. I normally don't do just capacitor swaps and leave it at that. So this is a more in-depth story of what dead capacitors can lead to and how easily the faults can actually be repaired. And this equipment here is a treadmill, and yes, I do know how to operate this machinery, albeit carefully. And I actually used this last on 2 days before Christmas Eve. And when I should use it, or my son should use it yesterday, it was totally dead. And it showed the dreaded E1 error that is a common error on treadmills. And normally that is due to a bad motor or motor steering. But this is an AC motor mill. So it has a frequency converter and not just regulator for DC motor. And I didn't know what to expect, but actually I was thinking, okay, this is probably some dead caps, because this is a unit that gets quite warm and it's a frequency converter. That means that you have capacitors that is subjected to high frequency. And they have probably not used the most expensive capacitors for this. So I dismantled the unit and took out the controller unit. And the only thing I had for a fault finding guide, if you can call it that, is what I found on the web page. And in Norway this is sold as the Sportsmaster T3000. I've seen it as the T3000 some other things. It's called the X1300 someplace, and it's called the RunFit 87, and it's probably manufactured and sold under a lot of other names. And this is what the vendor actually had in their store for a repair or service guide for this unit. And this is the troubleshooting guide that's available on the internet and also downloadable from the Sportsmaster webpage. And here is stated that this can be caused by a belt, or that the regulator, or not regulator but sensor for the motor is bad. And this is optical or Hall effect sensor. It's probably a Hall effect sensor. I didn't look into it that carefully. That stands on the spindle of the drive wheel and not on the motor. So if the motor is running and the belt is slack, this will also give an error. But in my case, the belt on the motor checks out just okay. It's changed just 2 or 3 years ago, and it actually has little wear. And it also say that you can try to start a mill again, and of course, as a computer guy, I've always tried power on at least 2 times. And then I started looking into more of the details on this, and then I got a bit disappointed, because these pictures here, it's not the same board that actually was in my mill, and the LEDs and stuff that is described here is not the same. So and here you can see the troubleshooting diagram. It's all empty, so this is clearly not finished by any means. But this is one of the places I had to look, and I also had this other general error code guide, and this is actually for a newer version that's called the 300BT, that stands for Bluetooth, that has some other. It's just the top place where the computer are that's changed, and I do think the motor assembly and everything else is the same. And here it says that E01 can be inverter, make this a bit bigger, can be inverter power with low voltage. And then it comes with the general replace filter or shock or inverter in turn. And of course there is no filter in this that you can change that has anything to do with the voltage. I'm not sure what this is meant to be a poor translation of, but there is a power inverter, of course, because it's a frequency controlled mill. So I did, as I said, take out the control unit. And please be so kind to disregard the dust and stuff that's in here, but actually this treadmill is actually a dust magnet of a great magnitude, because it does have a lot of statics when you are walking on it, and it draws dust like no other device in my house, including the vacuum cleaner, I think. And here you can see that you have one bulging cap here, and you can see the bulge on these two here. It's a bit dark here in the picture, but at least the three caps here has been leaking, and you can see them here on the cut here, that it's almost functioning as a valve on the capacitor. And all the other ones have quite the straight top. So now I'm going to do like many others do on the internet. I'm just going to change the cap that is bulging, and I do think that this will make this go again. So I'm not going to recap anything else, just the three bulging caps, and we see how that brings us. Yeah, here I have dismantled the unit, and as you can see, it's quite a sturdy design. The design with using this aluminium bracket as the cooling, and it's also stamped to the bottom of the treadmill, so it's quite the good cooling capacity for this unit. But when we have to desolder something on this, we have to take into account that this is solder that is unleaded, and that means that it has a higher melting temperature. So I just check with my desoldering gun to see if I can actually make a dent in this, but I can't. So the first thing that is wise to do here is to mix this with some leaded solder to get the temperature and the melting point for the solder a bit lower. So here I just mix up and resolder the points with a good leaded solder with some rosin flux, and that will make it much easier when I do the desoldering with the desoldering gun. And I also raise the temperature a bit on the Hakko 301 desoldering gun. And I won't say that is a walk in the park, but at least it's melting much easier now, and I'm able to suck up most of the solder that was encapsulating the pins in the holes for these components. Yeah, the Hakko 301 is a really good device if you keep it clean and that you have the right temperature for the job. Yeah, the next part here might seem a bit brutal, but I'm only using these pliers because there is some glue that is gluing these capacitors to their neighbors, and I need to twist it a bit to get this loose. But when the glue is loosening, the capacitors is just falling out of their holes. Looks kind of like pulling teeth, but without the sadistic part. Yeah, the caps that we now have taken out of the board is both rated at 105 degrees Celsius, and the first one is 100 microfarad, and the second two, the big ones, are 330 micro, and they are all rated at 25 volt. For the 100 microfarad, I find a replacement that's rated exactly the same. It's a bit smaller physical, but I do think it will fit the purpose. But when I look into my parts bin, I can't find any 330 microfarad, that's 25 volt. So I pick someone that's 470 microfarads. That's a bit more, but it's a 105 degree component and it's rated at 25 volt. So I do think that will be okay, and the 330 caps are probably filter caps anyway. Yeah, before we do any soldering, I will clean up the solder pads with using just some soldering wick, and I do this on both sides so that I know that there is no stray solder lying around and that the pads are clean and shiny for taking new solder. And then it's the easy job to just solder in the three capacitors. We have placed them now in the holes with them in the right direction. And in Norwegian we have this rule. You have the cathodes or minus lead is cathodes, and in Norwegian you have the term for short that is kort. So you remember that the cathodes and cot is the same, and that's just a rule because these capacitors are nicely marked for where the minus lead should go. But it's always nice to remember one extra rule to make sure you don't make mistakes, and that the short one is the cathode is a good rule of thumb. Yeah, the soldering process goes nice and easily. The only fault I done is that when I started heating one of the capacitors, it fell through the PCB, so I have to put it back in again. And when you do rework like this and you use leaded solder, it's always a joy to see how much easier the leaded solder flows on these boards than the non-leaded solder. But of course I do have non-leaded solder if that's a requirement, but I think it's both easier and it makes a better solder joint than the modern types, especially for us amateurs that has learned soldering with leads back in the day. As this board with some spacers tie right into the aluminium, I make sure that the legs are cut to the right length so there are no possibilities of my soldering shorting out something against the aluminium. And it's also a good idea to wash off all the extra flux, and as I've soldered this in 2 steps, it's a lot of flux that I need to wash away, and I just wash this away with some isopropanol alcohol and some cotton buds and a bit of paper to remove the residue. When we are mounting this back together, it's very important to remember that the silicone pad, the pink thing here, should be intact. This is an electrical insulator, so means that the module in the back here does not get shorted to the aluminium. The rectifier bridge is plastic housing, so that clamps straight to the aluminium without any pad in between. And it's also important to remember that when you clamp anything like this down to aluminium, you can't use unlimited force on the screws. It has to be firmly attached so that you have good thermal conductivity, but you must not crush the plastic of the housing of the modules. It's also wise to try to use the same torque on both sides of a module like this so it clamps evenly to the aluminium. And then it's just the 4 screws in the corner, and they just clamp onto the standoffs on the aluminium. And then it's just plugging in the top module, and that has 1 metal standoff, 1 plastic, and just 1 plastic clip. And then it's the leads that we need to reconnect, and then it's just putting it all back in the opposite direction as it came out. I do not show this clearly here, but I do clean the heatsink for the old cooling paste and put on some new paste before I mount this in the bottom of my treadmill. I don't know how warm this module gets, but as they have applied all this cooling inside here, and there is also actually a fan on the back of the aluminium that to my opinion goes nowhere. It should be a bigger fan that was placed more away from this aluminium lump.
15 minutes later.
And as you can see, the treadmill is turning, so that means that the steering is working as it should. And it seems to me that it's going with the normal force and speed that it should. I do have to take a longer walk on it to make a final test, but so far everything looks good. So, did we learn anything from this? Did we just get lucky, or is these caps bad, and is this the only caps that was bad? And first now we test these caps with the 1 kHz signal, because we don't know what frequency they actually was working on in this circuit, but there was some kind of switching involved, and it's not 50 Hz, that's for sure, or 100 that it would be with a normal rectifier. And here you can see that this is clearly not good. It should be 330 microfarad, and that it's clearly not is. It's about 24 on our measurement here. Let's take the other one and see if it's about the same. And when we do manage to get the leads connected and not obscuring the display, we see that this is actually messing out a bit better. It's over 50 microfarad, and that's also measured with 1 kilohertz. And if we quickly adjust the peak tech down to measure this at 100 Hz, we see that the capacitor values gets a lot better. This is measuring in about half of its marked capacity, but it's still bad, of course. So increasing frequency, lowering capacitance. And just to have it done, we measure the first capacitor also with 100 Hz, and we see that this also about doubles its measurements from 1 kHz, and it's measuring in about 80 microfarad. And the last capacitor was 100 microfarad, also a 25 volt, and we measure this out just now with 100 Hz, and we can see that it's less than a third of its rated capacity, and of course that you can count as bad. But should this circuit have been working with these caps? I don't think so, and we have just tested them now in a static test. When you apply some current through them and make some load over time, they might behave very different from what we now test on the bench. But I do think that if anyone is watching this, some of you are screaming, but what about the other caps? Ain't they bad too? And I don't think they are. I think that these 3 caps was operating outside of their limit for actually working over a long time, as we was discussing in the last video, the MSX keyboard video where I had the capacitor special. And this is very often the case. There are some bad apples with the capacitors, and they normally behave like that because they have been abused in the circuit. The rest of the caps probably do just fine and will probably last as long as these replacement caps that probably will get the same ill use as the old ones and probably will stop working in 5 or 6 years or something. So that's it for this short video. Hope you enjoyed the contents. Please leave a comment below if you want to discuss any of the topics. Please hit like and subscribe, and hope to see you in the next one. Thanks for watching.